pH is defined as the negative log of H plus. If we have the H plus concentration, we can calculate the pH. In this problem here, we're given an H plus concentration of 4.7 times 10 to the negative 11 moles per decimeter cubed. If we plug that into our equation, we're going to take the negative log of this number. That will give us a pH of 10.33. In terms of significant digits, we have a new rule that we need to follow for pH. The number of digits following the decimal point in pH is equal to the number of significant digits in H+. In the last problem, we had 4.7 times 10 to the negative 11 moles per decimeter cubed as our concentration. This has 2 sig digs, meaning that our answer needs to be to 2 decimal places for the pH. So we would record that as 10.33, and that would be to correct significant digits. To go backwards to calculate the concentration of hydrogen ions from pH, we're going to take 10 to the negative power of our pH. So if we wanted to go reverse, we're going to go 10 to the negative 10.33. Our sig digs are based on the number of decimal places in our pH. So this would give us 4.7 times 10 to the negative 11 moles per decimeter cubed. pOH is similar to pH. It's a way to describe the hydroxide ion concentrations. The equations for pOH are very similar to pH, except we're substituting in OH concentrations instead of H plus concentrations. To calculate the pOH of a solution then, we're going to do pOH equals negative the log of 3.0 times 10 to the negative 6. If we plug that into our calculator, again, we need to remember that we have 2 significant digits here, so our answer needs to be to 2 decimal places. This gives us a pOH of 5.52. The relationship between pH and pOH is derived from the expression H plus times OH minus is equal to Kw. If we took the log of both sides and used our log rules, we could derive this equation here. pH is equal to pOH plus pKw, where pKw is equal to the negative log of the Kw. This is equal to 14. If we plugged in 1.0 times 10 to the minus 14 for Kw, we would get 14 as our answer. So that means that pH plus pOH is equal to 14. This gives us a nice, quick, easy way to figure out a pH if we're given pOH or vice versa. For example, if we have a pH of 6.4, what is the pOH of the solution? We're going to set up pH plus pOH is equal to 14. So 6.4 plus pOH is equal to 14. That means that pOH is equal to 7.6. To use these all in combination then, let's look at this last example. We have HNO3, which is a strong acid. So a strong acid is going to completely dissociate into its ions, into H plus and NO3 minus. we are given a starting concentration for HNO3. So that means that when this dissociates, we are going to have 0.042 moles per decimeter cubed of both H plus and NO3 minus. We have an H plus concentration, so we could find pH as the negative log of the H plus. If we calculate that, again, we got 2 sig digs, so 2 decimal places would be 1.38. We could find pOH by taking 14 minus our pH. This would give us a pOH of 12.62. And then to find out our OH minus concentration, we're going to take 10 to the negative 12.62, which gives us 2.4 times 10 to the negative 13 moles per decimeter cubed.